Thank you to everybody who's joining us online for this seminar, which is part of the Martin Center seminar series here at the University of Cambridge. This is our first and last seminar of this term, as the other three programmed were postponed on account of strike actions, but we will return to those next term after the Easter break. But today we are honored to have Chris Wright and Matt Jones here presenting on the 3Ds of 21st century energy systems: digitization, decentralization, and decarbonization, which fits very well with our seminar series theme of emergence and how architectural solutions emerge from challenges, for instance, energy crises. That being said, I'll hand off the microphone now to Chris and Matt. Thank you for joining us.
Thank you for having us. So I'll get straight into it. Just introducing ourselves. My name's Matt. I'm a head of design at Lunar, and that really means kind of joining all the dots between all of the things that we're making: hardware, software, UX for apps, brand communications, etc. And prior to joining Lunar, about a year and a bit ago, I was at Google for a long time, and then before that was in part of an independent design studio called Berg that did a lot of connected products and Internet of Things type research. And with me is Chris.
Hi there. Yeah, so I'm the head up the sort of software technology and product and design teams at Lunar. And have been involved in this space for more than 10 years, building out platforms and technology to deliver this sort of new way that the energy system can work. And before, that was mostly developed in a company called Moixa, which was acquired by Lunar about 18 months ago. Mm-hmm. And originally, I trained as an architect at Cambridge. So I'm kind of happy to be back.
Virtually, at least. Yeah, so to talk a little bit about Lunar, it's a relatively new company, although, as Chris said, the company that he co-founded, Moixa, has been going for about 15 years or so prior to Lunar's forming. Lunar's about 300 people, split across, broadly speaking, the west coast of the United States, where we're headquartered, and a lot of our hardware is being designed and built, as you can see in this little video, which for some reason isn't looping. Apologies for that. And in the UK, we're based here in London, which is where we're speaking to you from. But we have employees all across Europe who work, broadly speaking, on the software side of things, which is what we're going to talk a little bit more about today. The mission of the company, as it's formed, is to make a dent in the impacts of the climate emergency in a very specific way, which is to transition homes to 100% running on electricity, and electricity that is sourced renewably. We make hardware and software to do just that, and we're going to talk a little bit about that today. Our plan, as I said, our mission is to transition homes. Residential buildings are a huge contributor to greenhouse gases, particularly through using things like boilers for heating. In the States, using energy for cooling, particularly, which is one of the biggest loads there, obviously. And if we can move homes to 100% clean energy, then that will be a big, big, big contributing levering factor on getting to net zero and beyond that this century. Our two, the sort of yin and yang of our plan to help with that or contribute to that, be part of the solution there, is first of all through the products we make. We are making a home energy system, which will be launched this year. And then on the other side of that, creating software platforms that can start to stitch together these home energy systems into a decentralized, digitally native type of grid for the 21st century, which is broadly the topic that we're talking about today. I don't think I probably need to introduce this image to anyone here, perhaps, but if just briefly, this is the the visualization of the temperature of Earth across, I think, the last 200 or so years, visualized by Ed Hawkins of Reading University, infamously known as the climate stripes. And this visualization tells its own story. I think we all know where we are in terms of the impacts of anthropogenic climate change and what we need to try and do to mitigate against that. This diagram, perhaps not as well known, but one of my favorites. This is a scale that was proposed by a Russian physicist named Kardashev, looking speculatively at the energy uses of civilizations across the galaxy. It's quite a grand scope beyond kind of like thinking about residential systems. But the point of this is that there is a type 1 civilization in his scale, which is a civilization that has made use of all of the energy resources incident on its home planet. And by most people's reckoning, we are currently at a score of 0.7 on the Kardashev scale in terms of the amount of energy we could harness as a civilization. There are 4 orders of magnitude more. There's 4 orders of magnitude more energy incident on the Earth, just from the solar potential of the Earth, that we are not taking advantage of yet. And perhaps some of you are aware of this recent publication by Mark Jacobson called "No Miracles Needed," which is about the way in which we have all of the Lego bricks we need to build out this kind of civilizational energy system. We don't need to invent anything new particularly. We just need to kind of stitch it together and deploy it really, really quickly. And again, just another image to kind of underline this from Dr. Simon Evans just recently, talking about how in terms of energy generation, we have gone past the peak of fossil fuel utilization, particularly due to the rapid growth in renewables, solar and wind. They are, as he says, the cheapest deployable form of harvesting energy across the Earth for 96% of the world's population. So, as the book says, no miracles needed, no new stuff particularly needed, just the will and the means to deploy it and stitch it together, crucially. Which brings us to the sort of title of our talk and the topic, really, which is this idea of renewing and revolutionizing the way in which we distribute and manage this electricity, particularly from renewable sources, in a sort of new, sort of bidirectional, decentralized and critically sort of digitally native grid compared to the one that's been built out across most of the industrialized world, at least over the last 100 or so years. And this diagram, which I think is from the EU Green Energy Atlas, I really like, which sort of contrasts these different scales of the grid and crucially the sort of difference between the sort of unidirectional top-down industrial electricity grid that we see in most national grids across the industrialized world, to where we're heading, which is one which is much more decentralized, incorporates much more small-scale generation and transmission, and also crucially engages the homeowner or the sort of customer at the end as an active participant in the system. And we'll talk a lot more of that, principally through the lens of what we've been working on our product, our platform, Gridshare. So while we don't want this to be a sort of company advert, we are going to be talking through our own work as a sort of case study in this larger kind of paradigm of the 3Ds. And Chris, this is something that you kind of introduced to me when I was sort of joining. So perhaps you'd like to talk a little bit more about this as well.
Yeah, I mean, it may be worth sort of saying kind of like how the electricity system works as a system in terms of what it demands. So there is almost no energy storage on the electricity grid as a whole. There is actually a little bit in Divorneg, which is a kind of lake at the top and bottom of a mountain in Wales. But it's only about 2% of what the UK needs at peak. So largely, at any one time, the amount of energy that's being generated must exactly match the amount of energy that is being used. And in the old world, what happened there was you ran your gas-fired and your coal-fired and your nuclear-fired power stations at 90% of what they were capable of doing. And then you could very quickly, within a second or two, ramp them up or down if you needed to by a little bit. And that's how, unexpected things were coped with by the grid.
The sort of classic cup of tea.
Yes.
In the halfway through
the football match. Yeah. Everyone turns on their kettle and you manage that you need some flexibility. Now, that world starts not to work as you have much more renewables on the grid, because they're classically what's called non-dispatchable. They're not controllable in the same way. Now you can turn them off if you need to, but that's expensive. And so what you want to do is, if you want to move to a world which is much more powered by renewables, you need to start having some flexibility on the load side of the equation. So the ability to be flexible about when homes use energy, when businesses use energy, when transport uses energy. And that is possible by connecting all of the things that are in homes and businesses to a sort of internet type platform, which is what Gridshare tries to be, where you can coordinate all of those individual millions and millions of things in millions of homes, such that you can enable the grid overall to move from largely fossil fuel powered to nearly 100% renewable energy. And that's where we need to get to. And in our view, you don't do that without adding a lot of intelligence and sophistication to how both the grid overall is controlled, but also how all of the devices in your homes, and particularly the larger things, your electric vehicle charger, a lot of our customers have solar and batteries in their homes, and controlling those in a really intelligent way, which enables the grid to be responsive and absorb all of this new renewable energy, which happens when it happens. It happens when the sun shines, it happens when the wind blows. And how do you make that work?
And I think, if I'm right in thinking, so we've I'll probably skip through this slide. This is effectively kind of what Chris was just narrating. Some of the challenges, as he was saying, peak consumption, peak production, are things that we need to try and balance using this kind of digitalized intelligence layer across something which is much more of a kind of internet-like topology of a grid, rather than this kind of industrial top-down organization. So there are two solutions to this kind of mega trend, if you like. One is the sort of, the big infrastructural solution side, upgrading the grid as it is, creating a 21st century infrastructure for electricity transmission, using a lot of investment in kind of transmission lines, creating new sort of digitized overlays on that kind of national level of infrastructure. But then there's also the kind of the sort of digital enabling of this flexibility through software services. And that's kind of this idea of creating distributed, aggregated pools of storage and energy, which you can dispatch in the way that you would have, changed the operation of things like of fossil fuel plants, as Chris was describing, but doing it with software and doing it with kind of clean energy through aggregated home storage, whether that's EVs or home battery systems.
And from a customer's perspective, it's quite a different world. Like in the old world, your only job as a customer was to pay the bill. That was your only interaction with the energy system. Now, when we move to the kind of new world, which lots of our customers already are in, we get suddenly you're generating energy, you're storing energy, you're selling that energy back to the grid when the grid needs it. The grid are paying you for that. So you're not a passive part of the energy system anymore. You're explicitly an active part of that. And managing that so that that becomes beneficial for both people in their homes and for the grid is a critical need of this transition.
This is just a little 1-minute video, which is sort of outlining kind of, again, where Gridshare sort of fits in this picture. So hopefully you can hear this.
What is Lunar Gridshare? It's a platform that connects with batteries, EV chargers, heat pumps, and optimizes them for customers. It then stitches all of those devices together and flexes them up and down to help keep the grid stable. So what's unique about the Lunar Gridshare platform is that we simultaneously optimize for the end customer's bill at the end of the month, as well as the potential for them to earn revenue from flexibility or grid services. And that means that whenever we're controlling a device, we know that we're doing the best thing for the customer and for the system.
So again, sort of underlining that idea that the end customer, the homeowner, the person sort of installing this infrastructure for their home is now becoming a sort of active participant in this larger emergent aggregation of these both storage devices, these smart energy management devices and software, all sort of coming together and making the individual homeowner or building owner or whatever it might be much more part of an active participant in this grid rather than a consumer of energy. They're producers and participants in the grid. Try not to make that play again. So going into a little bit more detail about Gridshare, this is a visualization of storage batteries that are being managed by the Gridshare platform in the San Francisco Bay Area. So this is some data from fleets of batteries across the kind of Californian Peninsula area there, San Francisco Peninsula area, which are using are being controlled by our software, but also being informed by the predictions that our software is making for the demands that are going to be placed on the grid to sort of, as Chris was saying, be able to kind of balance the supply of energy to the grid out of these renewable sources. So I'll play this, and perhaps Chris, you can do a little voiceover.
Yeah, so you can see here the sun is beginning to rise, and the yellow bars are the solar energy being pushed into the batteries. So solar energies that can't be used in each of these homes being stored away in those batteries. As the morning goes on, you see the batteries start to be full. Like the solar is providing all of the energy that the home needs, and the batteries are now full. And we're working our way towards the afternoon, and suddenly the grid needs that energy because it's the peak of consumption. And you can see here Gridshare actively managing, swapping in and out batteries to provide the maximum amount of energy that's needed for that peak period as it goes. And that's, then each of those customers getting paid for delivering that energy back that they've stored for free from the sun, and delivering it not when the sun is shining, but when the grid needs the energy. And that's the critical thing that enables you to do that instead of turning on a gas-fired peaker plant.
Oops. And this is just sort of this might be a little bit hard to read on screen, but this is just sort of an overview of what Gridshare is doing, and there are other platforms attempting to do this in the marketplace, and lots of people doing research on these sorts of things. Obviously, we're a little bit biased about our product, but to use it as a sort of illustration of this kind of like new breed or new paradigm of kind of a digitized, decentralized and distributed energy system. So what you've got on one side, on the sort of far side of the sort of Gridshare cloud right there, are the sorts of the actors in the sort of traditional grid side. So these are sort of big power companies, the wholesale market, network services, the sort of national or sort of in the states, state level actors in terms of the energy system, both making requests to the software platform and receiving kind of dispatched power, as Chris was describing, to their grids. Coming in from the side on the sort of top left there, you can see data from sources that we're getting from commercial sources and from the internet around weather conditions, weather predictions, market data. Is power going to be cheaper? Is power going to be more expensive? Is it going to be sunny? Is there a storm coming? What are going to be the conditions which are going to affect not only what the large actors on the grid are going to be paying for, but also what are these new active participants, the individuals who are sort of aggregated into these virtual power plants? What are they going to be rewarded for? Should they be saving up energy to dispatch to the market, if you like, when it's more valuable? Should they be saving energy for themselves, for their household, because it's not going to be sunny, or indeed there's going to be some really sort of like adverse weather coming down the line? So being able to have this kind of ability to take in data sources and make predictions is a crucial part of this kind of digitized, decentralized grid as well. On the other side, in the bottom right, you've got things such as customer preference. These are resources owned by a family or an individual or a building owner or perhaps a school or something like that. What are their priorities? Does the school want to keep the lights on at all costs? Do you, as a homeowner, want to always make sure that your car is charged? What are your priorities there? So that's another sort of factor into the way in which your kind of like micro individual energy world is going to then sum up into this more macro emergent decentralized and digitized grid. And then just on the sort of bottom left, we've just got some notions of these different types of kind of actors which will have their own energy infrastructure running again at that, as their own little island, if you like, whether it's a home, and we're starting with sort of residential market as our sort of main focus, but also thinking of small businesses, as I say, institutions, libraries, schools, etc. And then also, and we'll talk about this a little bit later, things like EV depots, where you will have a lot of batteries with wheels, which can be used as a resource to be aggregated and dispatched in this kind of decentralized active grid that we're describing. And so in the Gridshare platform itself, you are not only kind of creating these predictions and these sort of models for action based on the data that you're absorbing from all of these different actors and from weather sources and market data, as I've mentioned. But crucially, you're also controlling these devices. You're giving them plans of action for what to do in these conditions based on these predictions. So that's what you saw in that visualization that we were just looking at, is a sort of overall aggregated understanding of what the grid needs, but then parceled out as individual control plans to these devices that might be as small as a homeowner's solar battery. Would you like to say anything about this, Chris?
No, fantastic summary.
And of course, as everybody has to have in their slides these days, we have a significant amount of machine learning and AI intelligence in this system as well, which is sort of analyzing these data patterns and using them to sort of inform these predictions and these plans of actions. And those predictions also are things that we then surface to the individual, so they can change if they like their preferences and anticipate, how they might want to modify their energy behaviors with these things in mind. So at this point, we were going to do a little bit of a demo.
I'd need to. Maybe we'll save that for later.
We might save that a little bit later because of our sort of ineptitude with Zoom. So we'll come back to that and keep going for now. But at the end of the talk, if we've got time, or as part of the sort of interactive portion, we'll show a demo of the software working live. Just another visualization. For quite a few years now, we've been working in Japan with the Gridshare platform, and across the entire nation, there are, I think this number is probably a little low now, 35,000 individual assets being managed by the Gridshare platform. And this visualization is a bit more ambient than the last one, but this is effectively the sort of ebb and flow of charging and storage across the entire nation of Japan, in terms of kind of demonstrating the scale at which this kind of decentralized, digitized grid can operate. This is not speculation. It's not kind of a near future vision. It's something that is happening right now and has been happening for quite a few years. This is, coming back to that kind of the title of that book, No Miracles Needed. We have all the stuff we need to create this kind of emergent bottom-up reactive renewable grid, and we've been doing it in Japan for quite a while. And so we strongly believe that this is kind of the paradigm of the next decade in terms of the energy grid. And I think it's kind of interesting to kind of think about it being this kind of like very active this topology, which has much more of a sort of active participation from individuals at the micro levels, but it's stitching together, as you can see here, up the sort of powers of 10, up the scales to the national and to the global level. And just as a sort of a really nice example of that, this is the plot on the left is a sort of less kind of beautiful version of what you just saw, but it is it's data from the Gridshare platform. I think September last year, when was it
Typhoon Nemadal?
Yeah, and a typhoon passed across the sort of southeastern tip of Japan. And on the right, you can see the path of the typhoon, and on the left is this the aggregated network of batteries responding ahead of time, ahead of the path of the typhoon, to store energy, make sure the grid is resilient, and dispatch it as needed by customers as that kind of adverse weather passed over. So this is this is a proof of kind of the grid being able to react to planetary data, if you like. This is satellite imaging, weather sources, radar imaging, detecting this typhoon coming, that data being ingested into a digital grid platform, and then the grid being able to respond in a resilient way to that through this kind of loop of sensing, understanding, predicting, and dispatching energy in real time, responding to real-time events, which I think is wonderful, and such a great example of kind of the way in which this kind of new approach can create a really, really different, almost organic way of reacting to the conditions around it. I said we'd talk a little bit about other sorts of batteries, big batteries with wheels on. This is another sort of part of the the picture really is, you know, that we start to get storage assets and energy assets everywhere we look. So as the EV transition runs in parallel to this grid transition, we start to see things, not just kind of individuals, EVs, homeowners buying electric vehicles and charging them at home, becoming part of their storage solutions, and by dint of platforms like this, part of this new type of web-like grid. But also bigger players like UPS, and this is a trial that we did with a few other partners in giving UPS two benefits really, using the same Gridshare software. One is being able to charge all of their vans in a smart way. That's going to save them money, make sure that their delivery vans are working as they need them to be, you know, dispatched and doing their deliveries, and timing those things well, and sort of treating these as things to balance, again, much the same as we do with batteries in the examples that we've shown before. But also then be able to offer up this aggregated, you know, giant building full of batteries on wheels as a thing that represents itself on this new grid. So suddenly UPS can say, you know, National Grid, we've got this thing we can offer, which is charging overnight. You can have, you know, this sort of window. We're willing to offer this up to you as part of the resources that you have available to balance the grid and provide electricity to people. So, you know, this building, this semi-anonymous building of brown vans somewhere in central London, is some kind of fractional version of a lake up a mountain in North Wales somehow, right? It suddenly becomes like an asset that can show up on the grid to store energy and dispatch it when it's needed, which is really, really interesting. And I think this is kind of something that again points to new types of, well, you know, new types of infrastructure, new types of building at some point around this.
Yeah, I mean, it's worth talking about what this means in the context of an old city as well, because, you know, this is actually in Camden, which is an old part of the city and has an electricity network that's been in, a lot of the electricity network was built in its current form in the 50s. Mm-hmm. And so whatever is there has kind of been put in there. Now you can upgrade that. So this building, we're looking at something like a £2.5 million bill to enable them to charge at the same time all of the 270 vehicles that they want to have in this depot. Now, that's not economic, but actually what we can do is say, look, well, we'll balance charging those. There's plenty of energy available through the night to charge all your vehicles. You just need to add the AI, add the intelligence, so that those batteries, exactly as Matt said, can play into the grid, can charge at the lowest cost, and can enable you to exist inside of a constrained city. Like, our cities are very constrained, and digging up the roads everywhere is just not a plausible thing to do. The same thing happens with homes, right? If you add an EV and an air source heat pump, so electrifying your home, electrifying you know, your space heating, electrifying your transport, you more or less triple your energy use as a home. Mm-hmm. Now, there's no way that the existing infrastructure can cope with that if it's not made smart. But actually, there is enough capacity in the network as it stands, but only if you add this intelligence, if you control when those things, if you control when they pull power, when they push power, how solar is best utilized that's on the home or your neighbor's home, such that you can sweat that infrastructure and make this transition affordable and doable.
There's an interesting, it's occurring to me, and you'll probably like look at me a little askance for me saying this, but as the more technically adept member of this duo, but it strikes me that there's another sort of resonance with the way in which packet switching and internet protocols enabled you to get more information down old copper wires, right?
Yeah.
Because you made it, you changed the way in which you're dispatching the information to be able to get much more flexibility and density into the same physics of that material,
rather than saying, okay, well, we just send data as a kind of a series of pulses. Well, suddenly it's like, well, what if you do that, but by phase changing it? So you send, some pulses at this phase angle, some at this phase angle, and some at this phase angle, and suddenly you've tripled the amount of data that you can send.
Yeah.
And yeah, that's a good analogy.
Yeah, and I think that's been a sort of really interesting. I think what you were just saying about kind of what that means for kind of existing fabric is kind of like, hopefully that's something which sort of brings what we're saying into kind of like an interesting generative provocation for everybody at the Martin Center and sort of looking into this agenda. And as I was very conscious that we were speaking to potentially a kind of a more architecture biased audience, this is a quote I've long loved, and I'm sure many others have, around kind of nesting things in scale, as we were just saying, but also kind of seems to be resonant with kind of what we're talking about in terms of this, the new possibilities that the energy transition bring, both to the infrastructure, but also to the typologies of the built environment around this transition, and just some kind of quick sort of notes on that. The recent, I think late last year, French legislation around turning parking lots into energy assets. You have kind of existing kind of energy, fossil fuel energy companies trying to, for whatever motivation, perhaps not entirely, selfless motivation, transitioning to green energy, clean energy. Up in the top right-hand corner is a prototype for an EV filling station in West London, in Fulham, by Shell, where you're having to redesign the existing kind of vehicle filling station into something where people have to wait for half an hour to an hour. So what does that mean for kind of how you design that, how it sort of integrates into the city? And just at the bottom right, other sort of interesting signals. My ex-employer's new HQ in California covered with what they call dragon scale solar panels as part of Heatherwick and Biggs, Bjarke Engel's development of that building. So again, kind of corporate HQs, institutions, buildings showing up as energy assets on the grid and being active participants. And what does that mean for the built forms themselves? Quickly just referencing another sort of really interesting book by a sort of urbanism academic from Taubman College, Malcolm McCullough, Downtown on the Microgrid, and he is a really wonderful. If you've ever read any Malcolm McCullough, it's always very lyrically written and beautiful to read. But in this little diagram, which I think again sort of illustrates just some of what we've been talking about, which is more about kind of I guess at the top of this, the top of this graph a little bit, like talking about virtual power plants. Gridshare is a software platform that commercially we speak much more to utilities and sort of national grids and folks like that about. But then sort of through these scales, again, through the sort of, the sort of powers of 10 or the Saarinen scales down to individual sites, private solar and storage, which we're working on, but also other things, community solar, institutions, as I've mentioned, district cogeneration, much more prevalent in Northern Europe. All of these things have a place in this new type of grid, the 3Ds we're talking about, and it's a much richer a sort of picture as McCullough says in his book. I would really commend this book to you. It's wonderful. And then just to finish off, just some other sort of signals, about kind of how people are speculating and thinking about how this might emerge. And on the right-hand side, a recent story from, streets that have come together in sort of community networks over a time of COVID, and now in the time of energy crisis are looking to how they could create collective action. How do they turn their street into something which is a sort of community resource participating in this type of grid? On the left-hand side, you may have heard of the genre of solar punk, looking to sort of near futures, which are much more oriented around kind of intermittent and renewable sources of energy rather than extractive capitalism around sort of the energy supply. And then in the middle, another sort of favorite of mine, which was suggested to me by Tobias Revel of Arup, and their sort of futures department, which he called breeze punk, where new materials and new technologies are starting to come online, which start to turn the fabric of our buildings into energy assets. This is a wonderful little paper from Nanyang Polytechnic in Singapore, which is looking at kind of a wind breeze harvesting, very little wind necessarily to generate electricity, which they're looking at using to coat facades and street furnishings and things like that. So just a few signals there of where we might be heading in this new sort of decentralized topology of the energy transition. And I think that was my last slide. So I will say thank you very much for your attention. And I think now we're going to go to more of a conversation, I hope.